Hi, this is statistics. We're going to go over lesson 1.1. There's an overview. Can Joy smell Parkinson's disease? So here's the setup. We watched a video in class. There is a link on the Canvas page to the video. And this woman named Joy Milne swears that she can smell if a person has Parkinson's, and it even transfers to their t-shirts. So she was given 12 t-shirts, half of which were worn by Parkinson's patients and half were worn by a control group. That means people that didn't have the disease. And she correctly identified 11 out of the 12 t-shirts. So, question, does this provide convincing evidence that Joy can smell Parkinson's? So, as we go through the questions, it helps you to arrive at the same reasoning that a statistician would. Number one, why would it be important to know if someone can smell it? Well, early detection of any disease helps. It helps with the treatment, and it could help figure out the cause of Parkinson's disease. Number two, how many correct decisions would you expect Joy to get out of 12 if she really couldn't smell Parkinson's? In other words, she was just guessing. Well, just like a coin flip would be 50-50, each t-shirt would be 50-50 if you're just guessing. It either has Parkinson's or it doesn't. So we would expect that she gets half of the 12 guesses right. 6 would be our expectation. Number 3, do we have some evidence that Joy can smell Parkinson's? Why? Yes, we do, because she did better than what we would expect if she was guessing. She got 11, which is more than 6. And if you think about it, proof would be 100%. But evidence means that it's more likely than not. So we definitely have evidence. And how many correct decisions out of 12 would it take to convince you or to convince you that Joy really could smell Parkinson's? Well, the answers can vary here, but it's definitely more than 6. It's significantly more than 6. We're going to establish a criteria for this later in the course. But if you were thinking 10, 11, 12, maybe even 9, then you're thinking the right way. So we did an investigation in class. We used a random number generator to come up with a way to evaluate how people would guess 6 things out of 12. And we put them on the board, and our dot plot looks something like this. We didn't get anybody in our class that got 11 out of 12 with their simulation, or even 12 out of 12. So since that's so rare, then we do think that maybe she does have a special ability, since she does way better than guessing. Each dot represents the correct guesses from one simulation of the experiment. So based on this simulation that's shown here and the one we did in class as well, the percent of the simulations having 11 or more correct identifications, 0%. So if she did it, but the simulation never did it, then we think, well, maybe she's not guessing. Maybe she does have a special ability. If Joy was guessing, her result of 11 correct would never happen purely by chance. Well, that's the end of lesson 1. See you in lesson 2.